and then predict the tone of the rest of the sentences, he uses this Naïve Bayes approach. So this is what he does. First, he takes one sentence. Let's take, for example, he takes a sentence, a manually coded sentence, and he breaks it into words. Then he removes what are called stop words. So stop words are just common words that you would say are not interesting. And since he's only doing a unigram analysis, he's only looking at words independent of each other, it's probably okay to remove stop words. He then stems the words. So if words have the same root, they'll be counted as the same word. Okay. Then he basically will count how many times each of these words appear in each category. Okay. So if you have all these positive sentences, he maps all the words that are in the list of positive sentences, and he gives a word count for how many times those words appear. And he does that for negative sentences, uncertainty sentences, and neutral sentences. And using that information, he determines from the tagged, manually tagged set, he determines that given a word, what's the likelihood that that word will be in the positive category or the negative category. So I have the word happy. Well, it appears 90% of the time in a positive sentence. Okay, based on the model we created, the manually tagged sentences. So by knowing these prior probabilities, it's basically creating a model from which you can predict the tone of any other sentence. So let's take a sentence that I know nothing about. I don't know if it's positive or negative. I take out all the stop words, I stem the words, and I look at each individual word, and I say, well, this word is probably denotes that it's a positive sentence because it's used more often in a positive category. But this next word is more often used in a negative category. But the next one's more positive, and so on. And you get these probabilities for every single word, and basically you add them up. And if you add up the scores and it's more likely to be positive than it is to be negative, then it's a positive sentence.
Can you talk about that on page 1064 also the issue that the context that often is used at sentence level, but you have to look at it also in paragraph level. I mean, that's where the flaw in the system is.
What page is that?
1064.
Yeah, I remember him mentioning that.
Yeah.
I think he says that
Paragraph is often it says the simple average of the tone of all sentences. Make an assumption.
what paragraph are you on?
The third one down. It says even though the algorithm performs all the slot validation tests, caveat doesn't order. The algorithm is used at a sentence level analysis in the paper, but it may not work well for analyzing past.
Yeah. That's right. So it could be this one positive sentence is actually within a story that's negative.
Right.
And he can't account for that. Yeah.
Can you even have that in a sentence? In other words, let's say take a word like profit is probably classified as being a happy word.
Or it's more often used in positive.
Positive word. But if the word not comes before it, that's going to change the tone of the whole sentence.
That's what he's.
Yeah, so
He takes it out. He takes it out. He takes out the.
I don't know if he takes out the word not. I don't know if that's considered a stop word or not.
Takes rid of the sentence actually.
No. He's in that case, Denise, there are certain forward-looking words that he took out because they're preceded by not, right?
Right. And that might be
But in this case, it's just any old word, like profit, preceded by not. Yeah, it's naive. So all the words are evaluated independently of each other.
modified this by deleting the following words and then stop words that not, no, on.
Okay, so let's see how accurate it is, okay? So how do you test the accuracy of a classifier like this? So basically, they use this n-fold cross-validation method. So you've got 30,000 sentences, and let's say you're using a threefold cross-validation. So let's use 20,000 sentences as the model, and let's predict what the other 10,000 sentences will be. And we know what the right answer is because we've already manually coded it. So let's see how accurate our predictions are. Then let's take a different 20,000. And then predict on the other 10,000 until, do that 3 times until all of the sentences have landed in the testing set. Okay. So that's a threefold cross-validation, and with the 3 categories or 4 categories, he gets about 67% or 60% accuracy. And it doesn't change much. So if he does the 50-fold, that means you're dividing the data into 50 segments, where each time through, one segment is the testing set, and the 49 are the training set. Okay? So is this good enough? So here's the baseline. He says, based on our prior knowledge of the percent of sentences that are that we already know are negative or positive or whatever, this is kind of the baseline to compare this to. That's why he adds this information, saying, oh, this is much better than just informed guessing. Okay, this naive Bayes approach. So yeah, I mean, it's a lot better. And so, but we know that a third of the sentences are miscategorized in terms of tone. Content does a little better if you lump them into 3 categories. Yeah?
Each one of these is running on 20,000 different tests, not 10,000.
No, just for this one. That's 2010. I mean, do you get how this works?
You did it 3 times and you did it 5 times.
So here you divide it into 3 10,000 chunks. Okay, that's 30,000. And you run it 3 different times, and each time you have a different 10,000 as the test set, the set that you predict on, and you evaluate the results. So by making the training set larger, basically is what this is doing. Do you get more accurate results? I mean, not really. Yeah. Okay. So any questions? So this is really typical of how you'll test the performance of a classifier, is doing a cross-validated test. Now he does say, I think in the paper, that in one of the tests he does, he just trains and tests on the same set. So he trains his algorithm on the 30,000. He builds his model, like I said, on the 30,000 sentences. Then he uses those same 30,000 sentences to classify. And you should expect a really high result, and it was around 90% or something like that. So well, he says that it's I don't know. It has to do with the fit of the model. I can't remember how he described it. Anyway, I don't want to. Yeah, ciao. The content I didn't really talk about it much. So here's the content categories. So whether the sentence had to do with revenue, cost, profit, or operations, or liquidity investing. So there are these 3 groups of content categories, at least he creates 3 groups. So do they have what? So every sentence was given a classification as, and it could be a classification based on tone and based on content. Oh, it does the same sort of exercise. So what it does is it says, it just has 12 different categories. So it has all the words in the same way. Like the word profit is most likely to be in this category, but it could also be used in another category. Okay? So there's a model for categories as well as tone. Of how what?
What the students were doing in the business. Hard for me to follow. Just an example from one of your statements you had, nutrition or whatever, what they actually did.
To classify it?
Yeah.
Let me. Yeah, this is basically a manually created model that says certain words are more likely to be in a positive sentence or a negative sentence just because they were found in those sentences more often. Okay? So I can't do a whole sentence. That would take a long time. Like that sentence. Maybe I can just create a fake example. Like. Well, let's just use the word attrition, okay, and nothing else. So just if there's, let's just say that's our sentence, okay, whatever. So the word attrition is found it's either positive, negative, neutral, I don't need a period there, or uncertain, okay? All right. So if the word attrition appears in our data set, let's say 100 times, okay? And 60 times here, 20 times here, okay. Then if we were just looking at the word attrition, we would think that there's a 10% chance it's a positive sentence, a 60% chance it's a negative sentence, a 20% chance it's a neutral sentence, and a 10% chance it's an uncertain sentence.
Because Lee gave them a list of words like nutrition, and then they pick these.
Well, he didn't give them a list of words. He just told them, go through these 30,000 sentences and tag it positive, negative, uncertain,
Okay, so this
or
sentence, presumably they would tag as negative.
most of the time. Let's say they did tag it as negative, and we go back and say, oh, in everything they tagged, the word attrition was in 60 negative sentences.
In other words, they also then said this sentence is negative, and the reason why is because of the word attrition.
No, not necessarily.
So
I mean,
so how do you get this count of attrition?
so this count would be like saying they classified all of these sentences as positive or negative. They didn't keep track of the words in them. But now we have a list of 30,000 sentences, and we know the content of all these sentences. We know whether they're positive or negative. Let's go back now and look and see what words are in those sentences. Now that we go back and look, we can figure out the probability of when we see a word, what kind of sentence is it going to be. And let's use that to classify sentences we've never looked at before. So they can take the word attrition and then 10 other words that form the whole sentence and get a probability for each word. And basically, you would kind of have all these different words, and let's say these are the different probabilities. And whichever number here is the greatest, that's the classification for the sentence.
So but there's 10 full words in this sentence, right? More or less. So this computer program, when it goes back and looks at it, how does it decide which of these words is the one that, or they classify every word, Medicare, commercial?
Yeah, every word except for the ones they've taken out. So they would have taken out the stop words, which could be like the word in, the word the word of, and they just leave everything else and they treat them equally. Of course, if there's a weighting scheme too, and I don't know.
For example, say Medicare.
Yeah.
Say it only appears 3 times in the 20,000 sentence. So then would they just discard that as not a word worth using, or and attrition? I mean,
Yeah, I understand.
Attrition. I mean,
He didn't say anything about that. He didn't say that he only looked at words that appeared in at least so many times and discarded the rest.
because say the word attrition. I mean, that's not a, it's not a word you see very often, right? So, you might just say experience a decrease, right? So, if it turns out that it's only used 4 times or used once in 20,000 times, but it's still clearly a negative word, wouldn't it be better if the students were allowed to say, okay, the reason we said this sentence was negative was because of the word attrition?
Yeah.
Would that be more efficient?
Efficient.
More efficient than the computer then trying to see now the computer to second guess the students, right? To say why did they decide it's negative, right? I mean, when they could just say, here's the word. Right?
Yeah. So this is like the baseline machine learning algorithm, Naïve Bayes. It's kind of the dumb statistical learning algorithm that at least that's how I see it, that you compare everything else to, the performance to.
Well, it seems a waste because you're going to the trouble of having manual intervention. Unlike a dictionary or something, somebody's actually looking at each sentence.
Yeah.
So why not
Collect more information.
Yeah, exactly. Collect from them why they decide this.
Yeah, I don't know why they wouldn't. Maybe they did, but it didn't make the cut. But yeah, anything to say, Juan? Okay. Is this clear to everyone how this works? Yeah, so I was surprised. Well, not surprised. I didn't think the classification accuracy could be much lower without raising some serious red flags. Yeah. Look, I can't explain it like I just did up here. The informed guessing has to do with, we know the probability of a sentence being negative, right, or positive, based on this, right? We know the probability of a sentence being positive, neutral, negative, or uncertain. You know it's something, but you don't know which. There are 2 other categories too, though. Neutral and uncertain. So there are 4 different options. And so I think what's going on here is given the test set, okay? So given the, and it never changes that much. So given the three different chunks, and knowing how many are negative, how many are positive, how many are uncertain, and how many are neutral, let's just make an informed guess as to what the other ones are. And I don't know if the informed guess is just always picking the one with the highest probability, which would be neutral. That would seem to get us at a number like this, since that's about how many of them are neutral. 32%, is that what it is? Or it's close to 39. But whatever they did, this is the baseline to compare to. So it's like predicting the weather. The baseline prediction is what was the weather like yesterday? That's what it's going to be today. Or what's the weather today? That's what it's going to be tomorrow. We'll compare all of our models against that to see if we can improve on it. So they're doing something similar. Like they're doing the dumb guessing, and this is how much they've improved. I didn't catch quite how they did that. Yeah.
Their dumb guessing is pretty bad. One's just guessed neutral and got 30.
Yeah.
It's really not improving much.
Well, maybe. Yeah, I agree.
So by making
Yeah, I don't know. I mean, maybe informed guessing is worse than dumb guessing. I don't know.
But even not using the Bayesian learning,
Uh-huh.
you're getting from 40. I mean, if you guess everything is neutral, you get 40%. So now you're getting an additional 20.
Yeah.
That's not very much. You're not improving much over just guessing neutral.
Well, it's a 50% improvement. Okay, so.
In a lot of these studies, don't they use random guessing as the benchmark? So in this case, it'd be 45%.
Well, but that's not fair since you already know.
Well, yeah, but if you didn't know anything, you just said 4 categories, pick one. That's random guessing.
Well, yeah, I mean, you'd get 25% then. I mean, at least you'd get. Maybe that's what they did.
Even so,
Yeah, maybe they just guessed. I don't know.
between the learning algorithm and informed guessing, right?
What's that? Yeah, there's a big difference. Yeah, I'd say that it's a big difference. It's not. Bayesian learning isn't perfect, but okay. So how do they calculate the tone of the MD&A? Basically, you take each individual sentence has been given a score. So if it's more likely to be positive based on the Bayesian probability they calculated, if it's more likely to be positive than anything else, then you give it a 1. If it's more likely to be neutral than anything else, give it a 0. And if it's more likely to be negative or uncertain, then they gave it a -1. And I think that's why he combined the two categories, so we could have the 1, 0, -1. I don't know. He said some explanation in the paper for why he did that. He said you could, if you broke it out, you'd get the exact same results as whether you combined it. So anyway, so basically you average all the sentence scores, and that's your MD&A tone. Yeah.
When he says uncertain, he means not that the student was uncertain, but that the tone was that the management is speaking uncertainly.
Yeah, it doesn't mean the. Well, now I'm getting confused with the next paper. Why don't you look that up for me real fast? Okay, thanks. Okay. Yeah, so it's an uncertain tone, not uncertain that the student doesn't know which. Yeah. Yeah, that's what I would have guessed. Okay. So if the average for the MD&A were to be a 1, that'd mean every sentence is positive. And if it were to be a -1, it'd mean every sentence is negative. Okay. So what do you guys think? What's the average MD&A across all MD&As? Do you think they're on average more positive or negative? Or do you think they're neutral? Oh, yeah. Well, you're right. Okay. So the average tone is a negative 0.23. So he breaks it down as well by in these 3 categories. So there are 12 categories, but he condenses them into, or puts them into 3 different ones. So you have a profit tone, a liquidity tone, and other tone. So the only one that's positive is this liquidity tone. So what else is in there? Yeah.
People saw there was an article in the New York Times yesterday, the science section. Did you see that about tone analysis?
Oh, no, I didn't. What did it say?
Because the scientists had looked at millions of novels or something,
Hmm.
books, in many different cultures, and they find that on a 7-point scale, they're all always positive. Even in bad times, it's still positive,
Oh, really?
right? And so they were saying that there might be a positivity bias amongst humans. That this is a very interesting article, and I was thinking of that. Well, it's surprising this is negative, right?
That's right. That's right.
They found that consistently across
Yeah.
time, across cultures in many different languages, it's always positive.
Right.
Even in bad news, it's positive.
Now, did they distinguish between fiction, nonfiction?
I don't know. I can't.
Yeah.
It's worth looking it up because yesterday,
Oh, yeah, yeah.
science section.
One of you can look it up if you want. But that's interesting. And then here in the MD&A, it's decidedly negative. I think that's interesting. Yeah, so I was going to look at this liquidity tone because it was the only negative one. Here are the categories. Liquidity, investing, and financing. So maybe it pays to be positive when you're talking about future of investing and financing and liquidity. All right. So like Yehuda was saying that earnings is mean reverting, regression to the mean. So is tone. So the author looks at all the firms in a certain quarter and divides them into quintiles. So here are the most happy 20% firms, and the most sad ones. And over time, he tracks their tone and finds that they are mean reverting. What's that? Newspaper articles? Oh, that's even more surprising.
Even if they're talking about bad news, they're still positive.
Well, she may have died a horrible death, but she was a wonderful person.
Yeah, or like, they would give an example, like there was an earthquake, but one person survived.
Yeah, that's right. Well, that's why they say, 900 people died, but it's a miracle because one person lived, and we're all happy. Well,
They also looked at books, websites, music lyrics, television shows, movies, and social media. 9 other languages.
Every single one. And what was the most positive? Does it say?
Oh, the social section of the New York Times. And they did the analysis just for the New York Times. The social section was most positive.
Oh.
Even the world news was the most negative, but even so, it's still positive.
Okay, so here are the results from the paper in terms of the determinants of MD&A tone. I don't know why they're blue, but I know why. Because when I changed the template to this Rutgers, it turned everything green. But this is just like a JPEG version of the previous one before I had changed the template, so it's still got the green color and not the blue color. Yeah. So it looks like they were mostly spot on. When firms perform well, then the MD&A has a more positive tone. Okay? And when there are high accruals, it's more negative. And he says that's a signal to managers, from managers to investors, that we know that the future of the business is bleak. because the accruals determine everything in the literature. Okay, well, all right, well, here's the major finding from the paper, I think. So they regress tone on, or future earnings on tone, and they look at 1 quarter in the future, 2 quarters in the future, 3 quarters in the future, 4 quarters in the future, and they find that the tone of the MD&A, he finds, does have a relationship with future earnings, but over time, the relationship dims. Kind of makes sense. It's beautifully laid out. And in fact, after 4 quarters, the relationship is no longer significant. So they do a similar analysis on the change in earnings. So if there's a positive or negative change, they find a similar trend. Okay. Oh man. Battery stretch. I know. I have at least half hour. I'll give these. I'll find a power cord. Anyone got a Lenovo power cord? No? Okay. So the next, is that Lenovo? Yeah. No, won't work. I don't care if it fits. I'm not putting it in. Okay, so this next little discussion, which is actually quite a long discussion in the paper, has to do with saying, why not use regular dictionaries that exist, lists of positive and negative words, and classify sentences or paragraphs that way. And here are some descriptive statistics of tone measures. Okay, so here there are 3 different dictionaries here. There's 3 different sources of dictionaries. So one's called Diction. I don't know if you guys have heard of Diction. Ciao, you heard of it? So Diction has positive and negative dictionaries. And then they do a cumulative tone variable. Then there's one called General Inquirer. That's GI. And that's the Harvard Dictionary. And they have positive and negative dictionaries. And then there's this one from called Luke. Some people call it LIWC, but it's been used in papers in accounting literature as well. It's developed by a guy, last name Pennebaker, Texas Austin. And they have positive and negative dictionaries as well. So you can kind of see how the mean values range quite a bit between. If you look at the positive dictionary for diction, you get 5.64. I'm not sure if that means, if that's the rate at which they occur. I think that is like 5% or something. The positive dictionary in General Inquirer and the positive dictionary in Luke. So they have different means statistics. And if you use these psychosocial dictionaries and you correlate them with earnings, this is what you get. So this is the tone variable created by the author of the paper. And it correlates with earnings this level. And here's Diction, General Inquirer, and Luke. And the illustration here is that the method of our author is much better than using the dictionaries that existed. Yeah. Yeah, that's not exactly clear from the table, but I would guess it's 1. Yeah. I probably ran a regression, but I just showed you this because it was cleaner.